In this video, we're going to be using trigonometric identities to transform one side of the equation into the other side of the equation. And here we're told that theta is going to be between 0 and pi over 2, which means it's going to be in the first quadrant. So all of our sines, cosines, and tangents, all of our thetas are all going to be positive. So let's take a look at letter A. Here we have the cosine of theta times the secant of theta, and we want to show that that does in fact equal a 1. So we're going to begin by writing down our cosine of theta over 1 times. Now, we know that the secant of theta equals 1 over the cosine of theta because that's one of our trig identities. Well, I can simply replace my secant of theta with 1 over cosine of theta, and then cosine of theta, cross that with cosine of theta, leaving me with a 1. And I've just shown now that my left side does in fact transform into my right side. Let's look at a slightly more difficult problem. Letter B says the secant of theta plus the tangent of theta, times the secant of theta minus the tangent of theta equals 1. So this one might be a little trickier to get it to turn into the 1, but here we have two binomials, so we're going to go ahead and FOIL this. So we're going to take the secant of theta times the secant of theta, which gives us the secant squared of theta. Then we're going to take our secant of theta times the negative tangent of theta, which gives us a negative secant theta tangent theta. Then we're going to take the tangent of theta times the secant of theta, which is going to give us a positive secant theta tangent theta. And then we're going to take our tangent of theta times our negative tangent of theta, which is going to give us a negative tangent of theta. Now from here, we can see that we have a secant of theta, tangent theta, and a negative secant theta, tangent theta, which is going to allow us to cross those off. It's like taking a 3 minus 3. And that's going to leave us with the secant squared of theta minus the tangent squared of theta. So how exactly are we going to get this to turn into the number 1? Well, if we think back to our trigonometric identities, we know that 1 plus the tangent squared of theta, that's what kind of gave me the idea, is the tangent squared of theta. So 1 plus the tangent squared of theta equals the secant squared of theta. So here I'm using my Pythagorean identity. Well, I can go ahead and I can subtract the tangent squared of theta from each side, and I'm going to see that that's going to give me the secant squared of theta minus the tangent squared of theta. Well, now that those pieces match, I'm able to go, okay, so I can replace that with whatever it equals, which is a 1. And so now I can see, well, they in fact do match. So I'm able to take the left side and transform it into the right side. Whenever I have a sine squared or a cosine squared or a secant squared or a cosecant or a cotangent squared, any of those things squared, I first look to my Pythagorean identities to see, can I use one of those?